Alright, so I don't have a worksheet that I'm going to use today because I just want to talk about some of the geometric underpinnings of early algebra. And on the back side of the board, I'm going to develop the questions I like to ask repetitively about linear, quadratic, and cubic functions. So we'll have at it on the back side, develop those skills, concepts, try to deepen understanding. But I just going to do a little play here, introduce piecewise functions, perpendicular lines. I'm hoping to get to the point where I've got thousands of worksheets made that I can connect with one of the classes that I taught, the progression there, so that I don't have to work so much creating the worksheets. Although if anybody is any teacher out there that wants to try this, AI, if you feed, I don't know, our department had fed one of the worksheets into the printer and asked AI to make copies of similar worksheets, just change the numbers, and what's taken me years to write, it's done in 5 seconds. Oh my God. So anyway, I'm babbling already. Let's just talk about some of the problems that you encounter early algebra. 25 minus 9. We call that a difference. And it sure does look like a difference of two squares. It would be nice to write this calculation, which I believe equals 16, as a product. And it turns out you can by working with the square roots, 5 and 3. Turns out if you add those square roots and you multiply by the difference of those square roots, you get 8 times 2. Boy, I just changed a subtraction problem into a multiplication problem. Why might that be helpful down the road? Because if we have some division, we simplify division often by dividing out common factors. So what are the factors of this subtraction? 5 plus 3, 5 minus 3. Now, how would we do it algebraically? Well, the textbooks don't use 5 and 9, although I'm doing it with my grandson right now. I'm having him learn this. A squared and b squared, that's what's in the textbooks. So I guess the square root of a squared is a and the square root of b squared is b, and I guess you can say that for all numbers, a plus b times a minus b gives you the difference of two squares. You can even put a 7 here. Haven't done this yet with you. They don't even have to be friendly numbers. How do I express this as a product? The square root of 7 plus the square root of 5 times the square root of 7 minus the square root of 5. So just putting some things in your head here. Middle terms cancel. And you get square root of 7 times the square root of 7, which is 7, and the square root of 5 times the square root of 5, which is 5. We just started a discussion. It turns out you can do the same thing with cubics. 125 plus 8. Working with the cube roots, 5 and 2. If we want to do the addition, which adds up to 133, let's see how we do it. We actually start with the addition of the cube roots. And then we multiply by what gets us back to 125? 25. What gets us back to 8? Positive 4. Doesn't work yet. But guess what 2 times 5 is? 2 times 5 is 10. So we say minus 10. Let's actually do this out. 5 times 25, 125. 5 times minus 10, minus 50. 5 times 4, positive 20. 2 times 25, positive 50. 2 times minus 10, minus 20. 2 times 4, positive 8. Sure looks like we can get rid of those. 125 plus 8 is now a product. Now what happens if it was a subtraction? Now I can't do addition of two cubes. There isn't a factored form for addition. Only subtraction. Okay? But If this was subtraction, we just change that to subtraction, and then we change the product so we get the cancellation. Works for that. Okay, so let's see if it does. I just changed things. 125 minus 8 happens to be 117. Hard to spot the factors, although I know 3 goes in now. 1 plus 1 is 2 plus 7 is 9. I would have seen 3 if you add the digits up. 1 plus 1 plus 7, if that can be divided by 3, well, here it is. There's your 3. 3 times what? 3 times 37, I guess. So I guess this is going to add up to 39, excuse me. 39, yep, 25, 35 plus 4, 39. Yeah, it works. So you've been introduced to something. All right, so let's see how you do. I'll just do one. Let's look at 125a cubed, and let's do the addition of 8b cubed. You can pause the video, and you can always replay what I'm saying here. All right, but you don't have to learn it on the spot. But I think the cube root of that is 5a, and I think the cube root of that is 2b, or not to be. That is the question, yes. 25a squared, that product is 10ab. I'll make it minus 10ab. You can do the double distributive, the double distributive property, I suppose we could call it. I don't know what else to call it. Foiling? I mean, does it work, foiling with 3 terms? I digest. 4b squared. You multiply this out, you'll get that. Unless I've made a real careless error. Just showing you that this discipline has evolved from people spotting patterns along the way once the rectangular relationship was born. Do you recognize the graph? Maybe not. Let's get that shape. Do you recognize the 0, 1, 4, 9 numbers? Those are the areas of squaring. So x in this case is area, came from the square root of 0, the square root of 1, the square root of 4, the square root of 3. So I go over 1 unit, over 3. I'm changing the x's now. Over 3, over 5, and what happens? I go up by 1. So we start here, I go up by 1. I go up by 1. I go up by 1. There's your shape. So that's a square root graph. Okay, so what do I start with? Pattern starts from 5. Square roots. Now I think we're not going to talk about the negatives. Right? We're not going to throw a negative in here or a negative in here. That's a lengthy discussion. We'll have it at some point. But right now, we're just going to throw a 5 in and say x minus 5. So 5 acts like a 0. But I'm going to go to, I want 2 units. Right? And when I drop in my second x is this one. I get the square root of 11 minus 5. The square root is 6 plus 2, which equals 7. Oh yeah, you're right, it doesn't. We don't like that number, we don't like that change, so we bring in the change we want. Oh, I hate this thing. Let's make that an 8. So that way we go, no, that's just too close to that. Let's make it a 9. All right, so how do you get from 2 to 9? Got to go up 7. There. Now none of the numbers are similar in any regard. We got to practice that. All right, what else we got? Well, do you recognize what that shape comes from? Hope you say absolute value, and you would be right. But I like to teach this as a piecewise function too. I like to introduce piecewise functions with this, but let's get this first. Y equals the absolute value. Oh, the absolute value of 0 is a minimum. You can't get smaller number out of an absolute value than 0. So therefore, I want -7 to act like a 0, and that's why I say x plus 7. Hope I'm recording here. I am. Good. And I want to get a 2. I think this is a familiar refrain. And it sure looks like I got 2 parts here that are linear. And it's V-shape up. So therefore my conversion has to be positive. It's got to be positive. Even though I'm looking from here to here, even though I'm looking to the left. How do you get from 2 to 50? You got to go up 48. And what's the change from -7 to 10? 17. And I like to write that as two parts. And one of them is to the left of -7, and the other is to the right. And the one to the left, here's my pieces. I always like to say Alfred Hitchcock. Right? Go back to the TV series and take a look at that. So one of them is going to be for my x is less than -7. That's one of the pieces. And the other one's going to be greater than -7. And I suppose I got to have an equal sign. Doesn't matter which one. We'll put it at the bottom one. Okay? So what do I have? Well, if I make this a parentheses, I got the equation of a line. And I know there's an arrow here pointing up, but you read graphs from left to right. So I'm going down, then up. Going down is a negative 48/17 x plus 7 plus 2. Going up, right? We got 17 units here, and that's a 10. Then this has got to be 24, I guess. Also gets me to 50. Right? So if I started it this way, how do I get from 50 to 2? Remember that was a 2. 50 to 2, I'm coming down. How do I get from 2 to 50? I'm going up. And all I have to do is change that to this. X plus 7 plus 2. And now I have a piecewise function. And the calculators and computers now, they have, I don't know, windows that show you where to type things so that you'll get the same graph as what we had before. But it's done in pieces. Pieces, we see pieces. Okay, I introduced this notation, I think, in the last video. G of x equals 7x cubed plus 4. G of x equals 7x cubed plus 4. And I asked you to find something. G of, I don't know, let's put a 2 in. Keep it simple. 2 cubed is 8. 8 times 7, 56, plus 4 is 60. So we just found that G of 2 equals 60. And then I introduced this notation. G minus 1. That's the inverse. What's the inverse? Of 2 gets you 60. We got to get a function that takes 60 and kicks it back as a 2. Okay? And remember, the method here is, I'm going to repeat all of this in the next lesson set, and the one after that, and the one after that, and the one after that. Exposure, a little exposure to each of these topics on a daily basis. And over time, I have found significant ownership of what you're looking at. All right, so how do I get the inverse? Well, let's just solve this equation for 60. Yeah, let's just solve it. And then what we're going to do is we're going to describe what we did. Okay, so that 60 is this x now. Okay, so let's pretend it's that x. And let's show all the things we're going to do. I think we're going to subtract 4. Let's put the x up here and keep track of what we do. I think we're going to subtract 4. I don't make my students, when they're at the board, show me -4, -4. I'm looking for that. And then we're going to divide by 7. So first thing I did was I subtracted 4. Then I'm going to divide by 7. Oh, I'm going to divide by 7, yeah. And then I'm going to take a cubed root. Then I'm going to take a cubed root. Well, that should be my function. Let's put 60 in and see if we get a 2. 60 minus 4, 56. 56 divided by 7. I might as well show it. 56. 56 divided by 7. Well, that's 8. And what's the cube root of 8? 2. that now becomes something we practice. The only thing that's difficult here, I think, in terms of people following this is they really got to do it from the first lesson set on. Unless I really just spend my retirement writing what are the new problems that I'm showing and when. I'm not going to do that. All right, I'm just not. I don't know any way to do it. Anyway, that's what that is. All right, so now we're over here with some skills. Let me get rid of what we covered already. Make some space. The final frontier. All right. I did introduce this writing exponential functions. I haven't really talked about how it works much or why it works, but let's just do it anyway. All right, so what do I see? I see that I have a graph that's above 10. Let's call it g of x. Might as well introduce something. G of x, let's call it above 10. Then the question is how much? How much am I above 10 to get to 17? Sure looks like I'm going up 7 units. Okay, I can see 10. I can see 17 now. Next time it's not 7. No, next time I didn't go up 7 because I got an x1 and I got an x2. And it's got to work for both. No, next time I did what? From 10 to 31. Oh, I went up 21. Here I went up 7. Geez, it looks like I tripled that differential. You know, I'm making some canned numbers here. And this course is based on zeros and ones. So 1800, I'm going to say x minus 1800. Let's put 1800 in right now. 1800 minus 1800 is 0. What is 3 to the 0? We've looked at that already. It's 1. 1 times 7 is 7 plus 10, 17. So I got that. But you know what? I didn't just change by 1 unit here. I didn't go to 1801. I went to 1905. That's 105 years. So let's do the math. Let's put 1905 in there. 105 divided by 105 is 1. 3 to the 1 is 3. 3 times 7 is 21 on top of 10. There's your 21 on top of 10. Let me make that a 3. Yep. All right, let's really push the needle here. I don't expect you to understand well, I think this might throw you a little bit, but if I don't start the conversation, it's never going to happen. Let's find the inverse. Well, first, I got to start with a number. I'll call it x, right, which is an answer to this equation. So if I was solving an equation, what would I do? I think I'd subtract 10. I think I'd divide by 7. I think 3 to the becomes a log. Oops, I need more space. That'll throw you on it. The inverse of exponentiating is logging, so let me start again. I solve by subtracting 10. Dividing by 7. The inverse of 3 to the is log base 3 of. The inverse of using an exponent is finding one. Dividing by 105, I got to multiply by 105. Subtracting 1800, I got to add 1800. Now let's see, we said 1800 got us what, 17? Let's put a 17 in here. Now I think it'd be easier if I did 1905. 1905 got us 31, I think. 1905 got us 31. So where am I now? So I'm going to plug 31 in. 31 minus 10 is 21. Oh, God, I've lost track of where I'm going. I got to start again. Excuse me, the old man's old. Let's put 1800 in. The heck with it. 1800 minus 1800, 0. Anything to the 0 is 1. That gets us 17. So 1800 gets us 17. Oh, I erased the whole thing. So x minus 10 divided by 7, log base 3, 105, plus 1800. Now we're going to drop 17. 17 minus 10 is 7. 7 divided by 7 is 1. What do you put on top of a 3 to get the number 1? That's 0. 0 times 105 is 0. And now we got ourselves 1800. We started with 17. And you're back to 1800. Now, I don't think you're going to process that on the spot, but I just put it in the old subconscious. All right. What else do we have? See, I'm losing track of what I've even introduced you to at this point. That's why I want to get to one of my worksheets. Can you do, let's go to the other side right now. Come back to this. Because I definitely don't want to lose you on the discussions that I want to have started on this back side. Write the equation of the line through 8, 3, 12, negative 2. You pause the video. You've had enough time to practice this now, 5 or 6 worksheets. I'm starting at 8, 3. So I hope you say x minus 8 plus 3. And then how do I get, now I don't do y2 minus y1 over x2 minus x1. I say, how do you get from 3 to negative 2? You go down 5. How do you get from 8 to 12? You go up 4. Okay, so there's the quickest, easiest way to write the equation of that line. It connects your x1 and your x2 to y1 and y2. All right, I also want you to know what the next coordinate is in that without doing any work. Well, I'm going to change by 4. So 12 becomes 16, and I'm going to go down 5, negative 7. And you should see that work. You should be able to plug 16 in and see how negative 7 comes out. Okay, 16 minus 8, 8. Well, 4 goes into 8 twice. 2 times negative 5 is negative 10, and negative 10 plus 3 is negative 7. That's what you're trying to practice. Then you want to be able to convert it to mx plus b. So we got minus 5/4 x. Minus times a minus is positive 40 over 4. I'm going to still work with the fractions here. Still going to work with the fractions because I wouldn't give you this problem. I want to make sure you can add. So 3 is how many fourths? 12 fourths. And so that becomes minus 5/4 plus 52 fourths. So that's a skill that I want you to have. Okay? Actually, this works out in our favor a little bit. No, it doesn't. No, I wish it did. It doesn't. So the next thing I want you to know is put it in standard form. Okay? And I haven't talked about that yet, but I'm introducing it right now. So standard form is something written like this. 2x plus 5y equals 20. Now, when you have a graphing form, it means you shouldn't have to do any work. You should be able to see what the graph looks like. Okay? Without any work. Minimal work. And so what's this course based on? Zeros and ones. Well, we're going to use zeros because if I let y equal 0, that's a pretty easy equation to solve. 2 times what is 20? When y is 0, looks like that's 10. What if I make x 0? Looks like y is 4. That, my friends, is an x-intercept. That's a y-intercept. So standard form allows you to graph x and y-intercepts immediately. And so 10, 0 might be out here, 0, 4 might be out here, and that's our line. So I want you to know that. And then I want you to be able to convert this is where a little work, to what we call the normal line at the calculus level, which is simply a fancy word for the perpendicular line. So let me do a little drawing. This is going to take care of our linear work, and so I'm going to start asking those on worksheets so that you get practice. It's a marathon, not a sprint. All right, so what happened here? It looks like, let's get this back. And I want it to go through, let's have it go through perpendicular line through, I don't know, something between 0 and 10. How about through the 0.59? All right, I didn't put that in the grades place, so let's just put it there. So I'm going to try to get a perpendicular line through 5,9. Well, I know 5,9 I can connect like that. So the only thing I have to do is find out what that slope is. All right, so we know we changed by 4 here and then 10 here. Okay, so it sure looks like it has something to do with 2/5. Yeah. So minus 4 over 10 is minus 2 over 5 as a ratio. So I'm going down to, now I got to do it so I really graph this well. I got to go down, I'm going to use the marker. 1, and that's going to be 2. That's going down 2, and over 10. 2, 4, 6, 8, 10 would be there. So that's my slope, down 2 over 5. So let's measure the perpendicular slope. Perpendicular, that looks to be about perpendicular. Let's get a better perpendicular. Okay, so that's perpendicular. Let's measure it. I think I'm going over 2. I'm just going to go over 2, and then I'm going to go up 5. Up 2, up 4, and halfway is 5. Over 2 and up 5. I made a stupid statement here. Oh, horizontal. Yeah, no. So I said it. Okay, never mind. So 5/2, right? Over 2 and up 5. I said it properly. Well, what's the relationship here? If you know the original slope, the perpendicular looks like the negative reciprocal. So if you're going down with one line, then you got to be going in the other direction for the perpendicular. So they're opposite directions. One is decreasing, the other is increasing. And if you have rise over run here, then the perpendicular is negative run over rise. Now, how are you going to remember that? I just got to keep doing it every day. We're going to memorize it over time. So don't think you're not going to see this again. Just take it in a little bit. And then we talk about it again tomorrow. That's how you get a working knowledge in this discipline. So I'm going to repeat it, and repeat it, and repeat it. Put a smile on your face. All right, now what do I want you to learn about quadratics? One of the most important things. Being able to write the equations. I'm going to make a canned problem for you, because then we're going to turn it into ax squared plus bx plus c. We're going to put it in graphing form, and we're going to find the roots, and we're going to solve it for another equation. And I'm going to introduce what the range is. All right, and everything I'm doing here, you can do in 60 seconds with enough practice. So 70, let me make sure I got, so over 4, 16, 32, so I'm going to go down 32, 40, 38. All right, so I'm going to make a canned problem. All right, so you try to write that equation. I'll make some room here. You pause the video, have a go. Each time I ask you to try something, if you've never seen what I'm talking about yet, then the first stage of learning is to follow, and I'm going to do it for you to get the conversation started. And then you're going to do it yourself as we go along, and then you'll hopefully explain it to somebody else along the way. Those are the stages of learning mathematics, I think. So, I have a x minus 5 squared plus 70. I'm going from 70 to 38, which is down 32 units. I've gone over 4 units for my second x. But if I put my second x as 9, the change, the quadratic change is not 4. It's 16. So you can see why I picked those numbers. Okay? So what do we have now? we have negative 2 times x minus 5 squared plus 70. All right, now maybe you couldn't square a binomial quickly and easily 5 lesson sets ago. That's how you judge your learning. Can you do x minus 5 squared quickly? We'll find out. So let's put that up here. Minus 2x minus 5 squared plus 70. And I'm going to leave that there because I'm going to show you how you can get the roots quickly and easily. In fact, I'll just look at that and tell you what the roots are. 5 plus or minus the square root of 70 over 2. Those are going to be our roots. I'm just looking at the graph. Okay, now I could be making a mistake, but I don't think so. So let's look at this now, and let's see if you can put it in ax squared plus bx plus c form. And if you can, but you couldn't 3 or 4 lesson sets ago, that's how you judge if you're learning. Anything that I introduced day 1, like just a minute ago, the normal and the perpendicular, I want to see you do it 4 days later. All right? Then you can see if you're moving in the right direction. All right, so I'm hoping you are writing this now as x squared minus 10x plus 25. And then plus 70. So what does that become? Minus 2x squared plus 20x minus 50 plus 70 is minus 50 plus 70 is plus 20. I'm sorry there are the same numbers here. Didn't mean that to happen. But it did. Now, where is the y-intercept? You plug a 0 in, and that would be somewhere around here, and you get 20 out. Which means we should also know a number over here now, and we'll play with that in a minute. We'll play with that in a minute. Okay, and it also hits the ground. If this was an object thrown up, then it's going to hit a 0 at some point, and that's what roots are all about. And we'll find that in a minute. All right. Let's find that right now. Let's tackle the roots right now because it's something we did before. So let's do it over here. Now that you have minus 2, x minus 5, where can I do this? Right here. Let's do it. I wish I had a classroom. All right. And we'll come back to this. Minus 2, x minus 5 squared plus 70. I want to know when that equals 0. What's the first thing I got to do? Move the 70. Addition becomes subtraction. Multiplication becomes division. What's minus 70 over minus 2? 70 over 2. Somebody's calling me. Let me just see who it is. I'll call her later. All right. And then what do we have? Undoing squaring, which is plus minus square rooting. And then the last thing we do is move the minus 5 to the other side, and there you have it. 5 plus or minus the square root of 70 over 2. All right, let's replace this with our answer to see how it becomes a 0. Minus 2 times 5 plus minus the square root of 70 over 2. Oh, inverse. Squaring plus minus. Oh, cancels. Squaring a square root gives you what's inside. Oh, negative 2 divided by negative 2. Negative 2 divided by 2 is a minus 70. Oh, this is gone now. And what's minus 70 plus 70? Yeah, 0. Found the roots real easily. And if I wanted this to go down to negative 1, well, then that would have been minus 71. Because how far is it from 70 to negative 1? 71 units. All right, now let's put it in graphing form. Trying to teach you to put it in graphing form. Which is that? Where did it come from? I got to do it again. Minus 2x squared plus 20x plus 20. Right? And we also said that you're going up at 20 to 1 here. And I'm going to show that with the cubic in a minute. Why that's true for any polynomial. You could have had cubics, quartics. That's the tangent. at that instant. Helps you graph things. But how do we get from here to here? You've been practicing it now for 2 or 3 times. I'm hoping your brain did that. The average of the roots. The average of the roots, well, a 0 gets us 20, then a 10 also gets us 20. Right? There's some symmetry. What's the number between them? Okay, and that's really embedded here. So, minus b, minus 20 divided by 2 times a, negative 2. What is minus 20 divided by minus 4? Bingo! 5. And then what do you do when you plug a 5 in? That's minus 50. Then that has to be 100. That was the last lecture in the last lesson set. 2 to 1. Got to be right. Plus 20. That's 50 plus 20. Oh, so we found that easily, and we found that easily. Now, why are we saying minus 5? Once again, 0 squared is a minimum. And if you put a negative sign in front of a minimum, you get a maximum. Okay, so I'm hoping you're following these discussions a little more based on what you've done prior to this. The practice you've gotten getting here hopefully starts to make more sense each time we do it. All right, so once I have that, all I have to do is take the minus 2. So we did find out that 5, so I say x minus 5 squared. We found that a 70 is what you get when you plug a 5 in, and you take the negative 2 because it's given, and there's the graphing form. What's the range? Every y value you're spotting here is either less than or equal to 70. That's what we mean by range. You look at your answers and you say, can I define the set of numbers that are in my answers? That's the range. Did I miss anything over here? Nope. One more thing to cover, and then some quick skills. Maybe I won't even do the skills on the back. I'll do them. You're well motivated if you're watching this. Put some more things in your head. All right, so I'm suggesting that at 0, your behavior is down 7 to 1, and you are at 0, 3. So I now know this graph at 0, 3, it's got to look something like, let's see, I want to make sure I'm saying, well, I got to find minus b over 3a first to know whether I'm to the left or to the right, because I know it's going to look like this. I know it's going to look like that. So minus b, I got a canned problem here. Minus b, 18 divided by 6 is 3. So, okay, so I now know that 0, 3 is there, and I'm going down at 7 to 1. And 3 is going to get me my point of inflection, and it's a 3 to 1 ratio here. So if I do this one, 2754, then when I subtract this number, I'm going to get minus 108. I'm just taking a shortcut here. Minus 21 plus 3 is going to tell me that I'm at minus 129. Right? Is that minus 129 plus 3 minus 126, I think? So I'm at minus 126. Could be making a careless error here. I can find this value quickly now and that one quickly. Not going to show you that yet. But I am going to show you why the tangent is what it is. All right? So I'm going to put a 0 in here. Well, that's 3. That's 0. That's 0. And that's 0. Now I'm going to put 0.001. No change. There's no change from that column. This one here, I'm going to change this number right off the bat. Oh, I changed it to minus 7. I forgot to change it here. Forgot to change it there. So if I put 0.001, then I get minus 0.007. But if I put 0.001 in here, I get minus 0.00. Let me see, x squared, 0.006 decimals, I think, right? 1, 2, 3, 4, 5, 6 decimals. So I think I got a 1/8 here. Okay, and if I put it in here, I got more zeros than that. So, you know, if I threw another 0, 0, 0, 0, 0, 0, these things disappear. But that is still going to be negative 0.007 divided by, now remember I did 3 decimals, 0.001. That's where the changes occur. And that's down 7 to 1. Right? So it doesn't matter whether I had a 5x to the 4th here. When you throw a 0.01 in here, whew, you know, that would just do 1/10. Okay, what happens when I square 1/10? I get 0.01. 0.1 times 0.1, something with 2 decimal places. That's small. Okay, and the more I do it, if I do 3 times, okay, you get a smaller number. You start with 1/10. You multiply it by 1/10, you're getting a smaller number than what you started with. Okay, all right, so I hope that that makes some sense. Okay, just putting some thoughts in your head, and your head might be spinning right now. That's okay. Been through this campaign lots of times. It stops spinning when we do it more and more, and you hear it more and more, and you keep working with it more and more, to the point where these things become, oh, that's simple. Okay, so there's a playlist for cubics where I do 5 cubics in a row, putting them in graphing form, finding the value of the local max and min should they exist, finding the rate of change of the cubic at the point of inflection, graphing it, all under 60 seconds. Same thing with the quadratic. Takes practice. Okay, just like soccer, got to get a feel for the ball. Okay, so for those of you getting ready for your high school season and you're going to the weight room, I'm giving you a suggestion now. Get a ball and go find a factory wall and knock it against the wall to a piece of tape. And your game will improve, even if you don't use good technique. It'll still get better. All right. What's the exponent you put on top of a 3 to get a 9? A 2. What's the exponent you put on top of a 3 to get a 1/9? A negative 2. X squared minus 10x plus 9. How do you write x squared minus 10x plus 9 as a product? X minus 1, x minus 9. Multiply it out, you'll get this. How do we finish this triangle? If you got a 5 and you got a 6, square areas. 25, 36, then this one has to be 51, 50, 61. So what is this? Square root of 61. What's the opposite to hypotenuse? The opposite is 6 to root 61. What's the adjacent to hypotenuse? 5 to root 61. Nobody was speaking English when they asked this, so that's what the sine function is, and that's what the cosine function is. I'll do one last log. First thing I'll do is, math is a language. What's that asking you to do? Take the square root of 25. Now what's it asking you to do? After you take the square root of 25, cube it. Square root of 25 is 5. If I cube it, I get 125. What is log base 4 to get 8? Can't do it the way it's written, but I can write 4 as 2 squared. I can write 8 as 2 cubed. And then I can say, what's the exponent I put on top of 2 squared to get 2 cubed? And I can see it's 3 halves because 2x equals 3 halves. So let's do what we just talked about. Let's take the number 4, raise it to the 3 halves. You can do it 2 ways. You can take 4 cubed, which is 64, and then take a square root. Or you can take the square root of 4 and then cube it. Okay, and I don't care if I'm talking fast, because modern technology, you can replay what I just said. And replay it again. So maybe just watch the video today. You know, that would be a good way to do it. Just watch it. And go, oh, what the heck is he talking about now? And then watch it again tomorrow. You don't even have to have a pencil in your hand. Just watch it. Let the process unfold. All right, so just trying to give you a little practice, and then I'll see if I can find a worksheet that I can connect to so I don't have to keep writing the worksheets. All right, good luck.